For your response question, problem number 3, out of the 3 that I've given you so far, this is the easiest one, and I know that it says calculator yes, but you certainly didn't really need a calculator to do this problem. A squirrel starts at building A at time 0 and travels along a straight wire connected to building B. For 0 to 18, the squirrel's velocity is modeled in the graph above. So this is the graph. This is the graph of velocity. Very important for us to remember. And it's given as a piecewise linear function. At what times during the interval does the squirrel change directions? Now keep in mind what you have here. We're trying to figure out when the squirrel's changing directions, and we have a velocity graph. And we know that a particle, in this case the squirrel, changes directions when v of t changes sign. So we're looking for a sign change, not just to hit 0. And we can easily and quickly see that the velocity changes sign at 9 and at 15. So you can see in my answer, direction changes at 9 and 15 because velocity changes sign. And so that answer is perfectly acceptable as I have it written. Part B, we looked at this problem when we were getting ready for the exam. At what time is the squirrel farthest? Key words: most, maximum. In other words, when is the squirrel the farthest or the maximum away from building A? Now, we know that the squirrel is moving to the right from 0 to 9 because the area in that region is positive. The squirrel is moving to the left from 9 to 15 because the area is negative, and then the squirrel moves back to the right from 15 to 18 because the area in that region is positive. Now, because it's the most or the farthest, the concept here, ladies and gentlemen, is the extreme value theorem. Now, when you deal with the extreme value theorem, you have to somehow indicate that you are testing the endpoint. So here is the first endpoint. Here's the other endpoint. Then I have to consider the critical numbers. Now, I already have identified the critical numbers because I have the graph of velocity, and I already indicated in part A where the velocity was changing signs. So the next thing I need to figure out is the position of the particle at these times. So, well, that's going to be really easy because this is a geometry problem. They already told us at time 0 the squirrel was at building A, so that's why I said that the squirrel had not traveled anywhere and his position was 0. At 9, I'm going to use area, and I'm going to find the area of this trapezoid, literally geometry, and the area of that trapezoid turns out to be 140. Now, if I want to know where the squirrel is at 15, I'm going to take the area that I got in here, which was 140, and I'm going to find the area of this region, which is negative, because the squirrel's going back to the left. And in that region, you can see that from 0 to 15, I start out with the 140 that I had at 9, went back to the left for 50, and the way that I got that 50, that was the area of that trapezoid. And so at that time the squirrel is at 90. And then finally, if I want to know where the squirrel is at 18, I'm going to go back, I'm going to find the area of another trapezoid. So I'll take the 140 that I started with already, subtract the 50 that I found in 0 to 15, and then this area right here is 25 more units. So I add it in, and so now I know that the squirrel is at 115. So I can easily see that the squirrel is farthest from the building at 9 seconds, and the greatest distance is 140. Because it asked me two things. It asked me at what time, and it asked me how far. So if I just said 9 seconds and I didn't tell the distance, I would not get all the points, and this is an easy question. Letter C, looking for the key words, I want the total distance traveled. Now we know then that that means I'm going to take all the positive area and I'm going to keep it positive, but the negative area I have to switch the sign, so this becomes a positive 50. So notice when I wrote the integral, I showed the grader that I'm taking the absolute value of velocity. It's going to be the 140 from 0 to 9. It's going to be technically minus negative 50 or plus 50 plus 25. So the total distance traveled by the squirrel is 215. Moving on to letter D. Letter D wants an expression for acceleration, velocity, and total distance. And what they're looking for are three expressions or functions or however you want to think about it. All right, I'm going to clear the board. Am I going to clear the board? No, I think I'm going to use the eraser to clear some of this off. So I can use the picture up here, just in case I need something that I've already done. The acceleration, and we're going from 7 to 10. Well, if this is velocity, now remember, this is the graph of velocity, so acceleration is the derivative or the slope of velocity. So all I need to do is find the slope of that segment. And that's literally change in y. I take the coordinates, as you can see from my work. I took the two coordinates, 720 and 10, negative 10, and I literally found slope to get the acceleration. So the acceleration function is literally negative 10. Now, to find the velocity, that's what I'm doing in this part right here. If I want the velocity, I literally need the equation of that line, because that is a line segment over that period of time, and I need that equation. So I'm going to go to y minus y1, in other words, the equation of a line. I just found the slope of that to be negative 10, so that goes in place of my m. I already know that x is 7 because that is the time or the value somewhere in there. Yep. Or no, I'm sorry. I can use either one of those points, and I chose to use 720. Sorry about that. So I let x be 7 and y is 20. That's just from the points above. And notice that I cleaned that up. In other words, I distributed the negative 10 and I added 20 to the other side. Now the reason I did that this time is because I know that I need to find the position function. I have the velocity function, I need position, so we know that I need to integrate velocity. So my velocity function, as I just found out, is negative 10x plus 90. I'm going to find the antiderivative, so I'm going to use the reverse power rule, negative 10x squared over 2 plus 90x. Don't forget about plus c. Now, the question is, how in the world am I going to find the value of c? Well, look down here. I need an x value and a y value. I'm going to use the x value of 7, and then I need the corresponding y value, and the way that I find that corresponding y value is I go back up to the top and I find the area from 0 to 7. And so when I find the area from 0 to 7, again, knowing that the squirrel started at 0, from 0 to 7, back up. From 0 to 7, I'm simply going to find the area of this region right here. And I can break it into a trapezoid or a triangle and a rectangle, whatever you want to do. And that area is 120. So I put 120 in place of y, I put 7 in place of x, and I solve for c, and c turns out to be 265. So that's really not that bad of a problem, and I hope this video has helped you in knowing how to solve the problem. And if you have other questions, come and see me.